Hi, this is James from KnowThen.com. In this screencast, I'm going to look at JavaScript generators and how they can make asynchronous programming much more pleasant. A generator is a different kind of function that can be started, paused, and resumed. Let me show you what I mean with some code. I'm going to first create a regular function, then I'm going to change that function into a generator function. The function I will create is the hello function that takes a single parameter and returns a string, hello, plus whatever name was passed in. Now let's call this function, logging the return value to the console. Now at this point, generators are pretty new, and running this in Node.js requires passing the Harmony flag, which essentially enables generators and a few other things. Now let's see what gets logged. Nothing too interesting. So now let's change this function to a generator function. This is done by placing an asterisk after the function keyword. Now let's see what happens when we run this same script. Okay, this might throw you for a loop. We didn't get a string. It appears we received an object back. When we thought we were calling the hello generator function, we weren't. We were actually creating a generator object. To run this generator, we have to start it with the next method. First off, let me change the code up a bit. I'm going to create a variable for our generator. Then I'm going to call the next method on the generator and log what's returned. Okay, let's run the script again. So now we see that calling next returns an object with two attributes, value and done. Value represents the returned value. Done indicates if the generator ran to completion or not. I told you a moment ago that generators can be paused and restarted. The pausing is done using the keyword yield. I'm going to show you how to pause execution by yielding the string your name is concatenated with the name parameter. Now let's run the script again. The object returned has the same two attributes, done and value. However, you can see that the generator returned the new string as the value, and the done attribute is indicating that the generator did not run to completion. The way that we restart the generator is by calling next again. Let's run the script again. Alright, you may be thinking, this is interesting, but how does this help me? Well, if you don't care for asynchronous programming using callback functions, and frankly, who does, then you can use generators to abstract some of that nasty code away. I want to reiterate a point that you probably already noticed in my code examples. Generators do not control themselves, they must be controlled by code outside of the generator. In my last example, I was controlling the generator by calling the next method. So I need some kind of code or library to execute my generators. Now there are several great generator flow control libraries already available, which is what I would recommend. However, I'm going to create a very rudimentary generator control function just because I think it helps you understand what's happening. Before I create my generator, let's look at how a typical callback function works in Node.js so we can contrast it with how our code would look with generators. I have this local module called weather, which I'll use in my example. The weather module has a getTemperatureByLocation function, which can take a callback or return a promise. I'm going to look up the temperature in San Francisco using the callback approach. I'll check for an error. If one's found, I'll go ahead and log it. Otherwise, I'm going to log the temperature. Alright, let's run this script and see what happens. Okay, this works, but it isn't particularly elegant. Wouldn't it be nice if we could do the lookup in more of a synchronous style, such as this? Well, we can get pretty close. Let me show you. First, I'll create a generator and look up the temperatures in a few cities. Then I'll write a generator runner that will execute our asynchronous code in our generator. First, I'm going to import the weather library. Now I'm going to create my generator function. Let's look up the temperature in San Francisco, California. I will yield the getTemperatureByLocation lookup, which, if you recall, will pause execution at that point and return whatever value is after the yield keyword to whatever code started the generator. So the question is, what value is returned by the yield in this particular instance? If you recall, the getTemperatureByLocation function can take either a callback or it will return a promise. So since we aren't using a callback, we'll get a promise returned. Okay, so after the temperature is returned, I'll log it to the console. Now I'm going to copy and paste the lookup and the logging lines above and change the cities to New York and Seattle. Okay, so this code inside our generator is structured very similar to synchronous code. It's nice and simple. Now the question is, how do we execute the code in this generator function? Well, we're going to go ahead and write a function to execute this generator. All right, I'm going to create a function labeled runner that takes two values, a generator and a value. This is a function that can be called recursively. The reason this function may be called recursively is because it doesn't know how many times the generator will pause or yield. So I'll have it check to see if the generator reports completion with the done attribute, and if it isn't done, I'll have the function call itself again recursively. I'm going to set up a variable called promise, which I'm mostly doing just to emphasize that our runner is only set up to handle yielded promises. Now I'm going to go ahead and call the next method on the generator and store the returned object into the result variable. If the generator hasn't run to completion, as indicated by the done attribute, I will set the promise variable. Now I will call the then method on the promise, passing in a function that the promise will call after the asynchronous lookup is completed. When I have the results, I will call the runner again, since we know the generator hasn't completed at this point. The second parameter to the then method is a function that will get called if an error occurs when doing the asynchronous lookup. I will notify the generator that an error has occurred by calling the throw method and passing the error into it. And lastly, we need to export our runner function so that it can be used by other modules. Now I'm going to import my runner function, and then I'm going to call the runner function passing in the generator. Let's run this script and see if it works. There you go, 3 temperatures logged, and the code was much more pleasant to write and look at. Well, hopefully that gives you a better understanding of JavaScript generators and their utility. If you intend on using generators, I would suggest you look into the Co library on GitHub, which is a fully featured generator flow control library. Thanks for checking out this screencast. Please consider joining my mailing list so I can notify you when I release new screencasts, as well as provide you with other valuable information. Thanks and goodbye.